Good morning, Chasm listeners. This is Mark Lefebvre, Conservation Planner from the Stearns County Soil and Water Conservation District, with this week's Conservation Report. With the current dry conditions and need for rain, I thought I'd talk about water management strategies to keep in mind while making irrigation decisions, and not only to inform farmers who irrigate about options to improve irrigation management, but also to inform the public about why and how farmers can utilize technology to conserve water and reduce potential nitrate leaching to groundwater. When making irrigation decisions, it's important to consider various water management strategies to ensure that water is used efficiently and sustainably. Also, to reduce non-point source pollution of groundwater and surface waters caused by irrigation, it is important to operate the irrigation system so that the timing and amount of irrigation water applied match crop water needs. Here are some strategies from the University of Minnesota Extension irrigation specialist Vasu Sharma to keep in mind. Early season strategies include, in the spring, always make sure the soil in the germination and early growth root zone is moist when planting. In Minnesota, spring rains usually provide this moisture, and irrigation at planting is not required, but if necessary, irrigate to wet this zone. As a plant grows, moist soil is necessary for proper root development, as roots will not grow through a dry layer of soil. A dry layer will result in a shallower rooting depth than desirable. For corn, experience shows that the soil water deficit can be as high as 60 to 65% in the early vegetative growth stages without affecting plant development. The root zone at this time may only be half to two-thirds of the crop's potential. Holding back on irrigation during the early vegetative growth stages promotes deeper root growth, increases the opportunity to store rainfall when it occurs, and decreases the risk of leaching valuable nutrients. Some mid-season strategies include, as the crop nears its critical growth period or usually peak water use period, reduce selectable allowable soil water deficit to minimize the risks of not meeting the crop's water needs and causing yield loss. For most crops, this may mean changing soil water deficit limit to 30 to 40% before entering the critical growth stage, such as the 10th to 12th leaf stage for corn or early flowering for soybeans. During this critical periods of water use, regularly project the next 2 to 3 days of water needs to plan ahead and avoid stressing any part of the field before it's irrigated. For example, when using a center pivot, which takes 3 days to cover the field, project what the water deficit will be after 3 days and use that to determine when to start irrigating. To reduce the leaching potential of a rainfall event, always consider the weather forecast when scheduling the next irrigation. Another possible irrigation water plan is to set the allowable soil deficit to equal to or slightly greater than the irrigation system's normal net application amount. For example, if the typical application is 3/4 of an inch net, then choose a planting deficit limit of 3/4 to 1 inch. If this is greater than 50% of the available water capacity in the root zone, make the amount smaller, especially during critical stages of crop growth, to reduce the risk of moisture stress. This strategy will require more irrigation applications than the variable deficit strategy described earlier. The next strategy is to use water budgeting approach, and this method involves calculating the water needs of the crops and the amount of water available for irrigation. Estimating soil water using the water budgeting approach is done by accounting for all the incoming and outgoing water from the soil root zone. Major inputs include precipitation or rainfall and irrigation. Major outputs is crop water use or evapotranspiration. Daily soil water depletion in the rooting zone is calculated using an equation. Various water budgeting tools are available for irrigation scheduling, such as the first is the Irrigation Management Assistance Tool, which is an automated irrigation software that works on the principles of water balance irrigation scheduling method. Another water balance irrigation scheduling tool available is the checkbook spreadsheet method, and this method requires daily data input, so it's no longer a very popular method. And the final strategy is to use soil moisture sensors. And one of the easiest and most effective ways to improve irrigation efficiency is to implement soil moisture sensor technology in irrigation scheduling. This involves measuring the moisture level in the soil to determine when and how much water to apply. This ensures that water is applied only when necessary and in the right amount. This is the method that we are encouraging farmers to adopt because it can help save water, and by monitoring the soil moisture and using computer software to help record and track the evapotranspiration, rainfall, and irrigation amounts, helps to determine when to irrigate. So if you're interested in learning more about irrigation water management, you can contact our office at 320-251-7800, and we can provide technical and financial assistance to implement irrigation water management, soil moisture sensors, or even variable rate irrigation. To wrap up, I'd like to announce that we will be hosting a cover crop field day on August 24th near Spring Hill. So save the date if you're interested in attending that. This is Mark Lefebvre from the Stearns County Soil and Water Conservation District with your conservation report, and thanks for listening this morning.